Okay, so today we're going to take a look at beyond the basics with proving triangles congruent. And majority of the proofs that we're going to have on these examples, and there's 6 of them, part of the given is going to be telling you something other than segments or angles congruent. We're going to use some of those new conclusions that we've talked about already, like what can you conclude when you know you have midpoint of a segment or an angle bisector, etc. So just like we've done before when we are proving triangles congruent, in this particular problem, we are trying to prove that triangle ZAK is congruent to triangle CAK. So those are our 2 triangles in the picture. So we know that our proof is going to have to end that way. Now again, we've talked about already, we have 5 methods for proving triangles congruent. Side, 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 angle, 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 side, or hypotenuse leg. Those do not change. And we still have to always get 3 pairs of congruent parts. So what we're going to do is start with the given. So the first part of the given says angle Z is congruent to angle C. And again, my reason is given, and I'm going to mark them with arc marks in the picture to show that they are congruent. I'm going to put an A in the margin because that's a pair of angles. Okay, next, I'm going to use the second given. So ray AK bisects angle ZAC. And again, that's given information. So if we use what the given tells us here, so if I use a different color here, and I have angle ZAC being bisected by ray AK. So if you need to, look back in your notebook or think, what happens when you bisect an angle? Well, if you think about it, when you bisect an angle, you get 2 congruent angles. So in this picture, they have to have vertex A. So it would be angle ZAK congruent to angle CAK. And that's a pair of angles, so I'm going to mark it with an A in the margin. And again, if you look back in your notebook for your reason, it goes something like this. If a ray bisects an angle, then it divides the angle into 2 congruent angles. So we're going to be using some of those new reasons that we've talked about already. So at this point, we have 2 pairs of angles, 2 A's here, and we always need 3 pairs of congruent parts to prove triangles congruent. So you got to stop and think, since we used up all the given, is there anything we can add to the diagram, to the picture? And hopefully you notice that these 2 triangles butt up against each other. They both have segment AK in them. So we could state segment AK is congruent to segment AK. Remember, that's the reflexive property. And since that's a pair of sides, I can put an S in the margin. So looking at the picture here, these 2 triangles, we have 3 pairs of congruent parts. We have 2 angles and a side, so you have to think, okay, is this angle, side, angle, or angle, angle, side? It is angle, angle, side because the side that we have, AK, is not the one between the 2 angles. So these 2 triangles are congruent by angle, angle, sides. Again, that part is not going to change. What's different about these proofs, if you have more, I shouldn't even say more complicated, but there's more steps. They're not going to tell you everything is congruent from the given. You're going to have to work your way through and figure out what can you conclude. Okay, so let's move on to number 2. There are 6 of them, like I said. And this second one here, we want to prove that triangle JKL is congruent to triangle MNL. Those 2 gray ones, okay? And again, that's how I know I want my proof to end. That's how I know I'm finished, if I have enough to get to that point. So we're going to start with the given like we normally do. So M is the midpoint of segment JM. That's given information. Okay, so if I look at it in the picture, keyword here is midpoint, and it's the midpoint of a JM, so I trace that there in pink. So if you think back to your note cards, and we talked about what happens when you have the midpoint of a segment. A midpoint divides a segment into 2 congruent segments. So if I'm picking off the pink segment, we would have to have segment JL congruent to segment LM. That's a pair of sides, so I can put an S in the margin. And my reason for this is based on this concept of a midpoint. if a point is the midpoint of a segment, then it divides the segment into two congruent segments. Okay, and again, that should be, assuming you have the note cards filled out from a few days ago, you should have the reasons there. Okay, now for the next part of the given, angle J is congruent to angle M. Again, my reason, it's given. I'm going to put an arc mark on the picture to indicate that, and that's a pair of angles, so I'm going to put an A in the margin. So I've used up all my given information, but I still don't have enough. I only have two pairs of congruent parts. So again, you have to stop and think, is there anything else I can add to the picture? And again, in this case, yes, you have vertical angles here in the middle. You got that bow tie picture. So we could state that angle JLK is congruent to angle MLN. And my reason, remember, those are vertical angles, so we would say something like this. If two angles are vertical, then they are congruent. Okay, and that's a pair of angles, so I can put an A in the margin there. Okay, so that should be enough if we're looking at it to prove the two triangles congruent. I've got three pairs of congruent parts. I have two angles and a side, so again, maybe you need to stop and think, is that angle, side, angle, or angle, angle, side? Notice in my picture, the side is between the two angles, so it's going to be ASA. The S is between the two A's. Okay, continuing on here, number 3. Now this one is not using some of those new reasons, but the reason I threw this one in is because it has overlapping triangles. Notice what I'm trying to prove here. Triangle EGA, I want to prove is congruent, excuse me, to triangle IAG. They're overlapping triangles. So again, for some of you, I know you struggled with the overlapping triangles before. So just like before, we're going to start with the given. So we have segment EG is congruent to segment IA, given information. And we have a second part, and again, I'm going to put an S in the margin to indicate the fact that I have a pair of sides congruent. Okay, next up, I have angle EGA is congruent to angle IAG. Again, that's given information. And I'm going to mark that in the picture. Also, that's a pair of angles, so I can put that. Now, I've used up both givens, so I have to stop and think, is there anything else I can add to the picture? So hopefully you notice that this segment AG is in both the pink and the maroon triangle. So that's a shared side. So I can say segment AG is congruent to segment AG. That is your reflexive property. And that's a pair of sides, so I can put an S in the margin there. So at this point, that is enough to prove the triangle's congruent. So I can state triangle EGA is congruent to triangle IAG by side angle side. Okay, let's continue on to the fourth one. So this one, again, if you look at the given information, you notice that I want to prove the triangle EVL is congruent to triangle IVL. Okay, so that's again how I'm going to finish. EVL congruent to triangle IVL. Okay, so just like before, we're going to start with our given. I need 3 pairs of congruent parts. So I'm going to start by saying triangle EVI is isosceles. And my reason, it is given information. Now, if you need to, look back in your notes. What do you know if a triangle is isosceles? Well, if you look, an isosceles triangle has 2 sides that are congruent. So in this picture, again, if triangle EVI, the big one, is isosceles, and if the base is segment EI, the sides that are congruent are going to be segment EV and segment IV. Since that's a pair of sides, I'm going to put an S in the margin for that. And my reason is going to deal with isosceles triangle. So it goes something like this. If a triangle is isosceles, then it has two congruent sides. So right now I have one pair of congruent parts. But notice I still have a given left. My other given is that L is the midpoint of segment EI. And again, my reason is given. So if you think back again, what does it mean when you have a midpoint of a segment? So if L is the midpoint of EI, what does that tell you? Well, if you think, a midpoint of a segment divides a segment into two congruent segments. So in this picture, if I'm picking the congruent segments off of the blue one I traced, it would make sense that it would be segment EL and segment IL. So segment EL is going to be congruent to segment IL, and my reason has to do with midpoint. So again, it goes something like this. If a point is the midpoint of a segment, then it divides the segment into two congruent segments. Okay, so again, I'm going to put an S in the margin to indicate the fact that I have another pair of sides congruent. So at this point, I've used both of the given information. I still need something else, but hopefully you notice these triangles butt up against each other. They have a shared side. So my other pair of congruent parts comes from stating that segment LV is congruent to segment LV. That is the reflexive property. And again, I can mark it with a pair of sides, an S in the margin to indicate that. So notice I have three pairs of congruent parts, so that is enough to prove my triangles are congruent by side, side, side. Okay, so we have two left. If we next look at number 5. So this one, notice we're talking about perpendicular segments in the given. So again, I'm trying to prove in the end that triangle DAK is congruent to triangle DRK. Okay, so again, if you want to fill that in a while, that's how we're going to end. So again, to be able to state that, I have to have three pairs of congruent parts. So let's start with the first given. So segment DK is perpendicular to segment AR. Now, if you remember, when you have perpendicular lines, what do you know? You have right angles. So in the picture, I traced in blue segment DK perpendicular to segment AR. So my right angles are going to occur here at K. So I can state angle DK, sorry about that. Try this again. So triangle DKA and triangle DKR on the other side as well are right angles. And my reason deals with perpendicular lines, or perpendicular segments, I should say. So we're going to say something like this. If two segments are perpendicular, then they intersect to form right angles. I'm going to do a little less writing because I'm running out of space. I'm going to put if two segments are perpendicular, then they form right angles. It means the same thing. Okay, so next I'm going to put my second given. So segment DA is congruent to segment DR. Again, given information. So if I'm keeping track, that's a pair of sides. Okay, now I used up my given, so I got to figure out something else I can add to the proof. So notice these two triangles butt up against each other. They have a shared side. So I can say segment DK is congruent to segment DK by the reflexive property. Now, if you think about your methods, I've got a pair of angles and two sides. I cannot prove them congruent by ASS. I'm not going to write ASS in my paper, but we said that works if you have a right triangle. In this case, I have right angles, and this one called a hypotenuse leg. So again, a right triangle, you don't write ASS. ASS only works for a right triangle, and again, then we call it hypotenuse leg. Okay, so we've got one final proof to take a look at, and that is number 6. So on number 6, again, notice we are trying to prove triangle CAN congruent to, and this actually is a mistake on my part. It should be triangle DNRA. or D-Y-N. I apologize for that. It's a typo. D-Y-N. So again, that's how I want to finish the proof, so I can fill in at the bottom if I would like to from the beginning. Again, once I can reach that point, I'm done. So again, we have to have 3 pairs of congruent parts to get there. So if we start with the given, we have segment AY bisecting segment CD. That's given information. So if you have to think, okay, when I bisect a segment, I'm bisecting segment CD. What happens? Well, you get 2 congruent segments. So if I'm picking them off the blue one, the 2 that are going to be congruent are going to be segment CN and segment DN. Okay, it's a pair of sides, so I can put an S in the margin. And my reason is going to go something like this. So if a segment bisects a segment, then it divides the segment into 2 congruent segments. I know it's a lot of the word segments in the same statement. Okay, so that's 1 pair of congruent parts. Next, I can use the second given. Angle C is congruent to angle D. Again, my reason is given. Since this is a pair of angles, I can put an A in the margin. So we've used up both givens. We still need something else. So if we stop and look at the picture, hopefully you noticed you have a pair of vertical angles in the picture. So we can state that angle ANC is congruent to angle YND. And again, my reason, if 2 angles are vertical, then they are congruent. So again, I can put an A in the margin to indicate that. So that is enough to prove your triangle's congruent, and my method is going to be ASA.